Imagine a world where the idea of terraforming Venus, the planet often called Earth's twin, moves from the realm of science fiction into the startling possibility of science fact. What would it mean to transform this hostile world into a viable new home for humanity? What staggering challenges stand between us and that vision? And what might such a monumental project teach us, not only about Venus, but about our own blue planet as well? Let's embark on a journey across time, science, and speculation, exploring the question, what if we terraformed Venus? Venus, as she exists today, is a hellish place. From Earth, she's a brilliant jewel in the sky, brighter than almost anything else at dawn or dusk. Up close, though, Venus is nothing like our world. She's shrouded in thick clouds of sulfuric acid, her surface temperature hot enough to melt lead, and her crushing atmospheric pressure is over 90 times that of Earth's at sea level. Even the Soviet Venera missions, robotic explorers toughened to withstand extraordinary punishment, lasted mere minutes on her surface before succumbing. Why then would we even dream of changing such an environment? Why choose Venus as our potential second Earth? The most obvious answer is that Venus, of all the planets in our solar system, is in many ways most like Earth. She's almost the same size and mass, with comparable gravity. Her position just inside the inner edge of the Sun's habitable zone means she receives a great deal of solar energy, perhaps too much now, but not impossibly much. If there were a way to change her choking, smothering atmosphere into one that could nurture life, Venus could become a wonderfully Earth-like world. But how do we get there? The process of terraforming Venus is not just a matter of sprinkling a little green dust on red-hot rock. It is, in fact, possibly the greatest engineering challenge humanity can imagine. The list of obstacles is as long as it is daunting. A dense, toxic atmosphere of carbon dioxide, almost zero water, a crushing surface pressure, surface temperatures above 450 degrees Celsius, acidic clouds, and the lack of a protective magnetic field. Each of these on its own would pose a nearly insurmountable hurdle. Together, they represent the formidable gauntlet that stands between us and a transformed Venus. Let's first consider the most prominent of these challenges: Venus's atmosphere. The planet's thick blanket of carbon dioxide has produced a runaway greenhouse effect, turning the surface into an inferno. To terraform Venus, this atmosphere must be drastically altered. There are several theoretical approaches to this Herculean task. One idea is to cool Venus by blocking the sunlight that fuels the greenhouse effect. Imagine gargantuan sunshades, vast orbital panels positioned at the inner Lagrange point, such that they cast a slightly cooling shadow over Venus's atmosphere. Slowly, very slowly, this might bring down planetary temperatures, though the sheer size of such a structure boggles the mind. To shade Venus enough to make any meaningful difference, these orbital shades would need to be about the same diameter as the planet itself, and built from lightweight, durable materials. Alternatively, more direct tactics might be considered. What if we could extract or convert that choking carbon dioxide? The gas needs to be removed from the atmosphere, ideally locked away somewhere safe. One method would involve seeding the upper atmosphere with engineered bacteria or nanotechnology capable of converting CO2 into solid carbon compounds or useful materials. Instead of clouds of acid, Venus would develop drifting islands of material that could, eventually, fall to the surface and accumulate as rock or usable substance. Yet even if we removed vast quantities of carbon dioxide, we would be left with another problem: what to do with that carbon? The surface is so hot and the pressure so great that rocks and minerals would have to sequester this carbon for tens of millions, or even billions, of years to prevent it from re-entering the atmosphere. Some scientists suggest that Venus's own rocks might readily absorb carbon dioxide as carbonate minerals, if only we could get the pressure and temperature right. But this process could take geological ages on its own. There is another highly dramatic solution, born of bold imagination and desperate hope: bombardment by icy comets or planetoids. This idea, originally proposed by Carl Sagan and others, imagines redirecting comets or water-rich bodies from the outer solar system to crash into Venus, delivering two things at once: water, and the energy to blast apart the carbon dioxide in the atmosphere. While tantalizing, this approach raises staggering technical and ethical questions. The energy released by such impacts would dwarf even the greatest nuclear arsenals on Earth, potentially risking massively destructive consequences not only for Venus, but for the solar system's orbital stability. Assuming, in some hypothetical future, we arrive at a point where Venus's atmosphere has been cooled and stripped of the overwhelming majority of its carbon dioxide, a new problem emerges: water. Venus today is bone dry. Over geological time, whatever water it once had has been lost to space, broken apart by solar ultraviolet radiation, and swept away by the solar wind in the absence of a magnetic field. To transform Venus into a habitable world, we would need to find a way to reintroduce water, vast oceans, lakes, and rivers. There are a few possible sources for this water. One is the scenario already described: bombarding Venus with icy objects imported from the outer reaches of the solar system. This would mean harvesting comets and redirecting their orbits, a task far beyond present human engineering. Each comet impact would be a cataclysm, but over centuries or millennia, Venus could accrue new oceans, slowly filling its lowlands and carving out new coastlines. Another approach relies on building immense orbital or solar system-wide infrastructure to funnel water directly to Venus. For example, water-rich asteroids could be towed to orbit, then harvested for their ice with vast arrays of space factories, vaporizing and directing this water down to Venus once surface conditions allow. Or, perhaps, even manufacturing water in situ from hydrogen imported from the outer solar system and residual oxygen in Venus's atmosphere. The logistics are difficult to comprehend, but not strictly impossible under the known laws of physics. Next, consider the challenge of Venusian days. One Venusian day is longer than its year, about 243 Earth days to rotate once on its axis. This long, sluggish day creates intense contrasts: prolonged baking under the relentless sun, followed by equally lengthy nights. Most Earth life is adapted to a regular rhythm of day and night, driven by our planet's 24-hour rotation. A terraformed Venus would need some solution, or life would need to be engineered to thrive under these unique conditions. One theoretical fix involves setting immense orbital mirrors to reflect sunlight into the night side of Venus, or blocking it from the day side, thus simulating a 24-hour light cycle. Alternatively, genetic engineering could breed plants and animals suited to the unique Venusian pattern of day and night. Some have even suggested, most audaciously, that humanity could spin up the planet itself by building gigantic solar sails or harnessing the energy of asteroid impacts to accelerate Venus's rotation. Such a feat would require energy orders of magnitude greater than anything humanity has ever harnessed before. There are other, more subtle issues. Venus lacks a strong intrinsic magnetic field, a feature thought to be crucial for protecting life from harmful cosmic radiation and the erosive power of the solar wind. Over time, without a magnetic field, atmospheres, even re-engineered ones, tend to be stripped away. Preserving Venus's new life-supporting atmosphere would require either constructing an artificial magnetosphere or establishing some form of long-term atmospheric replenishment, a sale of planetary maintenance unlike anything ever attempted. Assuming, though, that all these challenges are met, what kind of world might we create? In the earliest decades after terraforming begins, Venus would be a place of transformation and cataclysm. Her surface, long shielded from telescopic view by sulfuric acid clouds, would gradually emerge into the sunlight. There would be storms and earthquakes as the planet's surface responds to changing pressure, temperature, and the massive influx of water and solar energy. Eventually, battered plains and mountain ranges might be sculpted by rainfall and rivers. Landscapes would begin to take shape, dictated by Venus's distinct geography. Her hot-spot volcanoes, the highest of which towers more than twice the height of Mount Everest, would become dramatic continental backbones. Vast, low-lying plains, cratered and cracked by ancient eruptions, would flood, forming newborn oceans and lakes. Over tens of thousands, or perhaps millions of years, Venus's own brand of plate tectonics, different from Earth's but no less dynamic, could be triggered by the process of cooling and the redistribution of mass. Life, always adaptable and resilient, would find new ways to survive here. Perhaps in the beginning, hardy pioneer species, engineered lichens, bacteria, and robust plants could be seeded to help generate breathable oxygen, slowly enriching the atmosphere with every passing year. These first colonizers would thrive in the thin, passing sunlight and the strange days and nights, anchoring new cycles of life. As oxygen builds up, new, more complex life forms become possible. Human pioneers, settlers, scientists, explorers might arrive first in domed habitats, then in ever larger numbers as the atmosphere becomes more clement. Some would travel here to escape the constraints of Earth, others to study the new world being shaped before their eyes, and some simply out of longing for adventure. Eventually, perhaps, entire ecologies would be transplanted to Venus, adapted, engineered forests, grasslands, and seas full of life, built from scratch or carefully selected and modified. In time, Venus would echo with wind and alien trees, with birds and insects, and living, breathing complexity in every landscape. Yet it is likely such a transformation would not produce a world precisely like Earth. Even in the most optimistic scenarios, Venus would always bear the stamp of her origins. Her gravitational pull, slightly less than Earth's, would lend a subtle difference to every step taken there. Her skies, depending on how thoroughly the transformation was achieved, would perhaps be tinged with strange colors, turquoise or golden, depending on lingering chemical traces. Her surface would boast craters, vast volcanic rises, and a geology uniquely hers. One crucial outcome of successful terraforming would be the opening of a new living space for humanity, one nearly as spacious as the world we now call home. Venus's surface area is about 90% that of Earth's, making her by far the most promising candidate for a second Earth anywhere in our solar system. Where Mars offers barren red deserts and vacuum, Venus, if transformed, would offer beaches, rain, and perhaps even forests and fields stretching from horizon to horizon. The social impacts of such a transformation would be profound. A new world means new opportunities, not only for living, but for new forms of culture, governance, and society. The history of colonization on Earth is fraught with lessons, both glorious and terrible, about how humans reshape new lands and how those lands reshape them in return. A terraformed Venus could become the crucible for the next chapter in that history, an opportunity to build anew, to learn from mistakes, and to fashion something worthy of the sacrifices required. Yet with all such dreams, questions of stewardship, ethics, and responsibility loom large. Are we, as a species, entitled to reshape entire planets to suit ourselves? How can we ensure that our attempts at world building do not simply repeat, on a planetary scale, the environmental errors we've made on Earth? Would terraformed Venus be a backup, a new version of Eden, or merely an extension of old patterns? One possibility is that humanity would turn Venus into a living laboratory, a place to test the limits of our technology and our imagination. Experiments in ecological design, social structure, and resource management would be forced upon us by the very act of terraforming. In transforming Venus, we might learn wonders that pay dividends on Earth: how to prevent runaway climate change, how to manage complex atmospheric and ecological systems, how to build resilience into the very fabric of our civilizations. The act of terraforming Venus is not just a technical challenge. It's a patient, multi-generational project, perhaps even a work of art. The timescales associated with planetary engineering are immense. At best, centuries. At slowest, tens or hundreds of thousands of years. Those who begin the process may never live to see its end. Those who reap its greatest benefits may be distant descendants, living in cultures and technologies unimaginable to us today. To undertake such an effort would demand unprecedented global cooperation, remarkable foresight, and a sense of shared responsibility that transcends nation, generation, and ideology. The lessons learned about patience, ambition, and the value of life could become humanity's true legacy. In imagining the terraforming of Venus, we are also forced to reflect on our own world. The greenhouse effect that makes Venus an inferno, is a reminder of how fragile climate can be, even on planets once thought similar to Earth. The technological solutions proposed for Venus find eerie echoes in geoengineering plans floated for our own climate crisis. The question becomes, can we summon the wisdom to heal the only planet we know for certain is habitable, even as we dream of refashioning others? As we stand at the dawn of spacefaring civilization, the notion of terraforming Venus invites us to stretch our scientific and ethical imaginations to the limit. It is at once a warning, a possibility, and a challenge, a vision of what we might become, for better or for worse. If the day ever comes when the clouds of Venus thin, when its surface cools and water once again runs in rivers, when life, perhaps our own descendants, walk freely under a gentle sky where once was only storm and heat, we will look back on the long arc of history and wonder, how far can the will, ingenuity, and wisdom of humanity take us? If we can turn a hellish world into a haven, what other wonders might we dare to dream? And what, in the end, must we learn from such ambitions, both about the universe and about ourselves? The story of terraforming Venus is therefore not just the dream of space engineers and futurists. It is a meditation on hope, on the power and peril of human transformation, and on the ultimate quest to find or to create new homes among the stars.